Welcome to Intelligence Gateway.
Mastering Data Visualization, Lecture 4. In this lecture we will learn about advanced visualization techniques, visualizing data from heat maps to time series, heat maps and correlation matrices, visualizing patterns in and spatial data visualization, mapping the world of data, network and graph visualization, exploring connections and relationships, tree and hierarchical visualization, organizing and visualizing complex data, visualizing time series data, understanding trends and patterns over time. Visualizing data from heat maps to time series. Welcome to our presentation on visualizing data. In today's world, we are inundated with vast amounts of data from a variety of sources. It can be overwhelming to try and make sense of all this information, which is where data visualization comes in. By using visual representations of data, we can quickly identify patterns, relationships, and trends that might not be apparent from looking at raw numbers or text alone. Visualizing data from heat maps to time series. In this presentation, we will cover a range of data visualization techniques, starting with heat maps and correlation matrices, which are particularly useful for identifying patterns in large datasets. We will then move on to geographic and spatial data visualization, which can help us uncover insights and trends in location-based datasets. Next, we will explore network and graph visualization, which are essential for understanding complex relationships and connections in data. Finally, we will discuss tree and hierarchical visualization, which can be used to organize and visualize complex data structures, and time series visualization, which is crucial for understanding trends and patterns over time. Heat maps and correlation matrices, visualizing patterns in data. Heat maps and correlation matrices are powerful tools for visualizing complex data sets. A heat map is a graphical representation of data where the values are represented by colors. This allows you to easily identify patterns and trends in the data, even if it is very large or complex. Correlation matrices, on the other hand, are used to identify relationships between different variables in the data. By plotting the correlation coefficients between each pair of variables, you can quickly see which variables are strongly correlated and which are not. One of the great things about heat maps and correlation matrices is their versatility. They can be used in a wide variety of fields, including finance, biology, and social sciences. For example, in finance, heat maps can be used to visualize stock prices over time, while correlation matrices can be used to identify which stocks are most closely related. In biology, heat maps can be used to visualize gene expression levels, while correlation matrices can be used to identify which genes are co-regulated. Overall, heat maps and correlation matrices are essential tools for anyone working with large, complex data sets. Geographic and spatial data visualization, mapping the world of data. Geographic and spatial data visualization is a powerful tool that enables us to unlock valuable insights and trends hidden within location-based datasets. By mapping this data, we can gain a deeper understanding of how geography impacts various aspects of our lives, from economic patterns to social dynamics. There are many different types of maps and tools available for creating compelling visualizations. For example, choropleth maps use color coding to represent different values across regions, while point maps plot individual data points on a map. Heat maps, on the other hand, use colors to represent density or intensity of data points. By selecting the right type of map for our data, we can create clear and informative visualizations that help us better understand our world. Network and graph visualization, exploring connections and relationships. Network and graph visualization techniques are essential tools for understanding complex relationships and connections in data. By representing data as nodes and edges, we can uncover hidden patterns and insights that would be difficult to discern otherwise. For example, social network analysis uses graph visualization to identify key influencers and communities within a network of people. One powerful use case for network and graph visualization is in the field of bioinformatics. By mapping out protein-protein interactions or gene regulatory networks, researchers can gain a better understanding of how biological systems function and identify potential drug targets. Graph visualization can also be used in cybersecurity to detect and analyze patterns of network traffic, helping to identify potential threats and vulnerabilities. Tree and hierarchical visualization, organizing and visualizing complex data. Tree and hierarchical visualization techniques are powerful tools for organizing and visualizing complex data structures. By representing data in a tree-like structure, it becomes easier to identify patterns and relationships within the data. These visualizations are particularly useful when dealing with large datasets that would otherwise be difficult to analyze. One example of a tree visualization is the sunburst chart, which displays data in a circular layout. The innermost circle represents the root node, while the outer rings represent child nodes. This type of visualization is especially effective for displaying hierarchical data, such as file directories or organizational charts. Another example is the dendrogram, which shows the hierarchy of clusters in a dataset. This can be used to identify groups of similar data points and to understand the relationships between them. Visualizing time series data, understanding trends and patterns over time. Understanding trends and patterns over time is crucial for making informed decisions in many industries, from finance to healthcare. Visualizing time series data can help us identify these trends and patterns by providing a clear picture of how variables change over time. There are various types of charts and graphs that can be used to visualize time series data, including line charts, area charts, and scatter plots. Each type has its own strengths and weaknesses, and choosing the right one depends on the nature of the data and the story we want to tell. For example, line charts are great for showing trends over time, while scatter plots are useful for identifying correlations between variables. To create compelling visualizations, it's important to consider factors such as color, labeling, and scale. Choosing the right colors can make it easier to distinguish between different data points, while clear labeling can help viewers understand what they're looking at. Additionally, scaling the axes appropriately can highlight important changes in the data without distorting the overall picture. By taking the time to choose the right visualization technique and paying attention to design details, we can create powerful visualizations that help us understand and communicate complex time series data. Conclusion. In conclusion, the Advanced Visualization Techniques module in Mastering Data Visualization provides data practitioners with the tools and skills to take their data visualizations to the next level. By delving into more sophisticated and innovative techniques, this module equips visualizers to create compelling and insightful visual representations of complex data. The training introduces advanced chart types, such as heat maps, tree maps, and Sankey diagrams, which allow data practitioners to showcase intricate relationships and patterns that might be challenging to convey with traditional chart types. Understanding when and how to use these advanced visuals enhances the ability to communicate complex data stories effectively. Moreover, the module explores the power of storytelling through data visualization. Data practitioners learn how to craft narratives around data, weaving together multiple visualizations and insights to create a cohesive and impactful story. Storytelling adds context and emotion to data, making it more relatable and engaging for the audience. Moreover, the module explores the power of storytelling through data visualization. Data practitioners learn how to craft narratives around data, weaving together multiple visualizations and insights to create a cohesive and impactful story. Storytelling adds context and emotion to data, making it more relatable and engaging for the audience. The concept of dashboards and interactive data visualizations is also covered extensively. By creating dynamic dashboards, visualizers can provide users with real-time insights, enabling them to explore data interactively and make informed decisions on the fly. This level of interactivity enhances user engagement and empowers them to uncover hidden trends and outliers. Furthermore, the module dives into geospatial data visualization, enabling practitioners to plot data on maps and use geographical representations to gain geographical insights. This is particularly valuable for location-based analyses and understanding spatial patterns. Additionally, the training explores data visualization tools and libraries that support advanced visualizations, such as D3, JAYS, Tableau, and Power BI. Familiarity with these tools empowers data practitioners to leverage the full potential of data visualization platforms and create cutting-edge visuals. In conclusion, the Advanced Visualization Techniques module is a critical component for data practitioners looking to elevate their data visualization skills. By mastering these more sophisticated techniques, visualizers can effectively tackle complex data sets, communicate data stories with impact, and provide meaningful, actionable insights to stakeholders. As data visualization continues to play an essential role in decision-making and communication, the knowledge gained from this module will enable practitioners to stand out in the field and drive successful data-driven initiatives.
Thanks for watching. For more information, like, comment, and subscribe our channel.